All right, in this lesson, we are talking about factoring GCFs. So to start, we're going to do a review from last semester with distributing. And so the warm-up says to simplify the following expressions. And so we're not going to get like x equals anything. We are just simplifying this expression, and that means get rid of the parentheses by distributing. Okay, and so we are distributing a 3x to all four terms. And so when you do this distribution, you multiply coefficients, which are the big numbers in front. You multiply the coefficients, but you add exponents. Okay, and so 3 times 2 is 6. X to the first times x to the third would give us 4 copies of x. And then 3 times -5 is -15. X times x squared would give me x cubed. 3 times 1 is 3. X times x is x squared. 3 times -6 is -18, and we still have the x. And so our simplified answer is 6x to the fourth minus 15x cubed plus 3x squared minus 18x. Okay, here we've got multiple variables, but same idea. Multiply coefficients, add the exponents. So 5 times 2 is 10. A times a cubed would be a to the fourth. B times b squared would be b cubed. 5 times -4 is -20. A times a squared is a cubed. B times b is b squared. 5 times 3 is 15. A times A is A squared, and then we just have the B. And so something I want to point out is if we are distributing to 3 terms, our final answer should have 3 terms, okay? And so when we start factoring GCFs, we are doing this process in reverse. We are starting with this expression, and then we are trying to factor out what was distributed. So you can think of the word factoring as undistribute. Okay, and so when you are trying to find the GCF, the greatest common factor, that's the term that was distributed to each term. Okay, and so the distributive property backwards is called factoring out the GCF. Okay, and so when you're finding the GCF of the coefficients, our coefficients here are 5, -15, and 45. So just focus on the positive, 5, 15, and 45. You're looking for a number that divides each of those evenly. And so I always start with the smallest coefficient, which in this case is 5, and see if it divides the others. 5 divides 15, and 5 divides 45. So the GCF between 5, 15, and 45 would be 5. That's the greatest factor that divides all of them. Okay, and then for variables, it's actually a little bit easier. Between x to the 6, x to the third, and x squared, you just pick the highest exponent. Okay, and so x to the 6, x to the third, x squared would be the biggest value that would divide all of these evenly. And so our GCF for the variables, it is x squared. And so our total GCF includes the 5 and the x squared. And so that's what we are going to divide all 3 terms by, 5x squared. Okay, and so after we divide each of those, remember it's distribution in reverse. So we're dividing the coefficients, subtracting the exponents this time. And so my first term would just be 1x to the fourth minus 3x to the first plus 9, because x squared over x squared cancels. And so how you write the expression is you put the GCF out front, and then the remaining factor goes inside the parentheses. Okay, it seems like a lot of steps, but it starts to go really fast. Okay, and so looking at number 1, start with the coefficients. My coefficients are 4, 8, and 12. Start with the smallest one, that's 4. And 4 does divide 8 and 12 evenly, so that's going to be part of our GCF. And now looking at the variable, we have r to the 5th, r to the 3rd, and r squared. If it's written in order, just look at the last term. R squared will be what we are dividing by. So your GCF for r squared goes outside the parentheses, and we're starting with 1, 2, 3 terms, so we should have 1, 2, 3 terms inside those parentheses. Okay, 4 divided by 4 is 1. You don't have to write the 1. R5 over R2 is r to the 3rd. 8 over 4 is 2, there's a negative. And then R3 over R2 leaves me with just r to the 1st, don't write the 1. And then 12 over 4 is 3, r squared over r squared cancels. And so this would be our factored expression, basically undistributing. You can check your work by distributing that 4r squared back, and you should get your original expression. 4r squared times r cubed would give me the 4r to the 5th. 4r times negative 2 is negative 8. R squared times r is r cubed. 4 times 3 is 12 with the r squared. Okay, looking at this next one, I like to put little division bars under each term, just kind of help me focus. And then starting with the smallest coefficient, we have 12, 24, and 18. 12 is the smallest, so I'm trying to see if 12 would divide all of these evenly. 12 does divide 24 evenly, but 18 does not. And so when I discover that 12 doesn't work, cut it in half. And so we're going to try 6 next. Okay, and so 6 divides 12, 6 divides 24, and 6 divides 18. And so that's going to be part of our GCF. And then looking at our variables, we have h to the 5th. We have h to the 3rd, and then we just have h. And so h is going to be our variable GCF. So put the 6h outside the parentheses, and then leave room for 1, 2, 3 terms. Okay, that leaves me with 2h to the 4th. Remember, you're dividing the coefficients, subtracting exponents, plus 4h squared minus 3. Okay, and then again, check your work by distributing this 6h back to all 3 terms and see if you get your original expression. Okay, looking at number 3, I'm going to put all my division bars. Looking at my coefficients, between 24, 12, and 36, 12 is the smallest. So that's what I'm going to test and see if 12 divides all of them. 12 does divide 24, 12 divides 12, and 12 divides 36, and so that 12 is part of our GCF. Now, looking at the variable, we have w squared, w, and then no w's. And so we're not going to get a variable for our GCF, just the 12. And this happens a lot. You just have a numerical GCF, and that's okay. So 24 divided by 12 is 2 with the w squared. 12 divided by 12 is 1. Don't write it. And then 36 over 12 is 3 with the negative. And so once again, you can distribute that 12 back in and see if you get your original answer. Looking at number 4, my coefficients are 9 and 1, an invisible 1. And so when that's the case, 1 is going to be your GCF, and you really don't have to write it, but I think it's helpful just to visualize. And then looking at our variables, we have n to the 5th and n to the 4th, and so n to the 4th is our variable GCF. And so my GCF is 1 n to the 4th. I'm going to leave the 1 off when I write my final answer. 9 divided by 1 is 9. N to the 5th divided by n to the 4th would just be 1 copy of n. And then we have a negative 1 over 1 is 1. N to the 4th over n to the 4th cancels. And so what happens often is whenever you're left with 1, meaning this whole expression is canceling, a lot of people think that's 0 and they don't even write it. And so even Algebra 2 students make that mistake. They leave that 1 off. But remember, if you're starting with 2 terms, your parentheses should still have 2 terms. And so 1 is your placeholder when everything cancels, not 0. Okay, so looking at these harder examples, we have two variables, but it's the same idea. Start with your start with your coefficient. We have 45, 15, and 4. Looking at each term. And then our smallest number is 4, and it does not divide 45 or 15. So then we're going to cut it in half and try 2. 2 does not divide 15 or 45. So the best we can do here is 1. Just like that previous example, 1 is the best we can do. Next, we're going to look at just the x's. We have x to the 8th, x to the 4th, x squared. And so x squared is the smallest exponent. So that's going to be the biggest that divides all of them. And now we're going to look at the y's. We have y to the 5th, y to the 4th, y to the 3rd. So y to the 3rd is the most we're going to be able to divide each of these by. You don't want the denominator on bottom to be bigger than the top. That's why we're picking the smallest, because that will be the most. Okay, so our GCF here is 1x squared, y cubed. I'm not writing the 1. And then leave room for 1, 2, 3 terms. 45 over 1 is 45. x8 over x2 is x6. Divide coefficients, subtract exponents. y5 over y3 is y2. We have 15. I'm going to need more room. 15 over 1 is 15. x4 over x2 is x2. y4 over y3 is 1. Plus sign. 4 over 1 is 4. x2 over x2 cancels. y3 over y3 cancels. So just a 4 there at the end. Okay, last one. We've got A's, B's, and C's, and D's. So I like to underline each term with a division bar to see how many terms I'm dealing with. And then focusing on the coefficients, those numbers. We have 4, 12, 16, and 4. 4 is the smallest, so we're going to try that. 4 does divide all of the other numbers, and so that will be our GCF. Next, we are looking at the a squared, a5, a10, a3. A squared is the smallest, so that's going to be the most we can divide by. Next, we're looking at the B's. We have B1, B2, B1, B1. So B1 is the best we can do. And then looking at the C's, we have C to the 5th, no C's, C squared, no C's. And so if there's no C's in one of your terms, and in this case there's 2 of them that don't have C, we're not going to be able to include that with our GCF. And then lastly, only one term has a D involved, and so we're not going to be able to divide by D either. So our GCF here is 4a squared b. That's all we're going to be able to divide each of these terms by. So make sure you leave room for those 4 terms. I'm going to go ahead and copy down those plus signs. 4 divided by 4 is 1. You don't have to write it. A squared over a squared, 1. B over b, 1. And so the only thing that's left for our very first term is c to the 5th. 12 over 4 is 3. A5 over a2 is a3. B squared over b is just b. Third term, 16 over 4 is 4. A10 over a2 is a to the 8th. B over b cancels. C squared can't change. 4 over 4 is 1. A cubed over a squared is a. B over b cancels, and then we have D. And so this would be our final answer. All right, something that's very important that comes up very often is if your leading term, your first term is negative, you're going to factor out a -1, okay? And at least a negative. So instead of saying -1, we're going to factor out a negative GCF. Okay, and so when you write these division bars like we have been, if you see that your leading term is negative, automatically put a negative for your GCF. You never want to leave a negative as your first term. Okay, and then now, just like we were before, looking at your coefficients, we've got 28, 35, and 7. 7 is the smallest, so we're going to try that. 7 does divide the other numbers, so now we're ready to look at the variables. We have x4, x3, x2. x2 is the smallest. And so my GCF here is negative 7x squared. That's going to be outside the parentheses. You don't want a negative here, okay? You don't start your parentheses with a negative. So if you have a negative, you needed to factor it out. Now we can do our division. Negative 28 over negative 7 is 4. x4 over x2 is x2. 35 over negative 7 is negative 5. Be careful with that negative. x3 over x2 is x. Negative 7 over negative 7 is positive. And then 7 over 7 is 1. X squared over x squared, 1. Cancels to 1. Remember, you have 1 as a placeholder. And so something that's important to notice is when you distribute a negative, all the signs change. When you undistribute a negative, all the signs change. Okay? And so that same pattern will hold true for factoring. Okay, looking at this next example with 2 variables. I see a negative out front, so my GCF is automatically negative. Looking at my coefficients, I've got 3, 27, and 30. 3 is the smallest, and it does divide the rest. Looking at the A's, we've got A7, A3, A2. A2 is the most we can do. And then lastly, looking at the B's, we have B5, B3, and B2. And so B2 is the most we can do for the B's. Okay, and so sometimes they just ask, what is the GCF? And in this case, you would just answer negative 3a squared b squared. 3a squared b squared, the positive version is usually an option, so just be careful. Right, we're still going to have 3 terms, but be careful, all the signs are going to change. So negative 3 over negative 3 is positive 1. A7 over a squared is a to the 5th. B5 over B2 is b to the 3. Negative 27 over negative 3 is positive 9. A3 over a squared is a. B3 over B2 is b. Positive 30 divided by that negative 3 is negative 10. A squared over a squared cancels. B squared over b squared cancels. And so our final answer just has a 10 right there at the end, a minus 10. All right. Next, something that will come up in our next lesson is factoring out a binomial. So in number 1 here, x plus 3 and x plus 3 is a common factor to both terms. And so what we can do is write that x plus 3 factored out as if it were the GCF, and then what's left is just the x and the plus 5. Okay, and this trick comes up a lot, especially when you get to higher level math, is recognizing a common binomial. It'll save you a lot of time. Okay, here I see w minus 6 in common to both expressions. And so I'm going to leave it in parentheses and put it out front and then just collect what's left, the w and the plus 2. Okay, here I'm seeing a 2b plus 3 and a 2b plus 3. Those match. And so I'm going to write it out front, leaving it in parentheses. And then what is left is b squared minus 5. Leave that in parentheses as well. I didn't say that earlier, but what's left goes in its set of parentheses, just like b's went in a set of parentheses. This time our GCF isn't just a monomial, it's a binomial. It has 2 terms separated by a operation. Okay, this last one, we have 4n plus 7, 4n plus 7. So the 4n plus 7 is what goes out front, still in parentheses. And then what goes left inside the second set of parentheses is n to the 4th minus 3. In that order, keep the order the same.